Let's take a look at example 6.3.3. And it says, recall from example 6.12 that the temperature of coffee tea in degrees Fahrenheit T minutes after it's served can be modeled by T of T, T of little t, is equal to 70 plus 90 e to the negative 0.1 t. Okay, that's temperature. When will the coffee be warmer than 100 degrees? What they're saying is you take 70 plus 90 e to the negative 0.1 t, and you're wondering when that's going to be greater than 100. Now you do need to get 0 on one side. So I'm going to take this 100 and move it over. I'll rearrange this a little bit. I'll put the 90 e to the negative 0.1 t first, plus 70 minus 100 is greater than 0. So we got 90 e to the negative 0.1 t. 70 minus 100 is negative 30. So we got minus 30. It's greater than 0. Now where it cuts off is where this is equal to 0. So we're going to find out something called a critical value by doing that. So I'll set 90 e to the negative 0.1 t minus 30, and I'll set it equal to 0. Now I want to solve for t. And I believe I have these steps here from an earlier session. Step 1, get to par with the variable and the exponent by itself. Well, this is a part of the variable and the exponent, and I want it by itself. So I'm going to take this negative 30, move it to the right side. So I got 90 e to the negative 0.1 t is equal to 30. Still not quite by itself. There's a 90 in front of it, so I divide both sides by 90. Then we get e to the negative 0.1 t is equal to 30 over 90, which reduces to 1/3. Now the part of the variable and the exponents by itself. So we're going to take the natural log of both sides. So we've got natural log of e to the negative 0.1 t is equal to natural log of 1/3. Now remember, natural log has a base e. So step 3, use properties of logs to get the variable out of the exponent. When these numbers match here, then the log and those numbers are going to cancel. And we're left with the negative 0.1 t, and it drops out of the exponent. And this is natural log of 1/3. Okay, and then we'll divide both sides by negative 0.1. So got natural log of 1/3 divided by negative 0.1. And let's see what that gives us. So I got natural log of 1/3 divided by negative 0.1, enter. You get 10.99. Now this is going to be our critical value. This is where something potentially happens. So we got 10.99. And it starts off with t is equal to 0. Can't have negative time. And over here, in theory, we put infinity there. You could have the coffee sitting there for eternity. We know eventually it'd evaporate and things like that would happen, but we treat it that way. Okay, now we want to choose test cases. So you want to choose something between 0 and 10.99, something easy to work with. T is equal to 1 would be a good choice. Now over here you want to choose something greater than 10.99. I probably wouldn't choose 11. It should in theory be okay, but choose something a little further out. Let's choose t is equal to 100. Now we're going to plug these in to our equation right here. This is the point where we dropped the greater than when we went to the equals. So we're going to plug it into here. So let me write that down. Okay. So I got 90 E and then negative 0.1 times 1. You could also choose 0. That would have been a good choice. But since it's on the border, I chose not to use it. Minus 30. Well, let's see what that gives us. So I got 90 E. I don't think I need a times. So second natural log for E. Negative 0.1. Even though it's trivial, let me go ahead and put it in there. Times 1. Closing parentheses. We know multiplying times 1 doesn't change anything. Minus 30. And we get 51.44. Now let's plug in 100. So I'm going to do a second enter to bring up previous entry. And I'm going to change the 1 to 100. So I'll throw it in insert, throw a couple more zeros in there, and press enter. And this would be whatever you on your calculator you'd be plugging in. Negative 29 negative 30, I guess, when around it. Okay, now what we're looking at is 90 e to the negative 0.1 t minus 30. We're wondering, when is it greater than 0? Well, if you look where it's greater than 0, it'd be right here. So in response to the question, when will coffee be warmer than 100 degrees? Well, that'll be from 0 minutes to approximately 11 minutes. Now, if this had been at less than 0, then we would have chose over here. Now, I know negative 30 doesn't make any sense. It's not going to become negative 30, but for purposes of the test case, it really does not matter. Okay, and I think they rounded this means it takes approximately 11 minutes for the coffee to cool to 100 degrees. Until then, the coffee is warmer than that. But that would be that example.